Hi everyone, and welcome to our video on accumulated future value. So we're going to let R of t represent the rate per year of a continuous income stream. Let K be the interest rate compounded continuously at which the continuous income stream is invested, and let T be the number of years for which it is invested. Then the accumulated future value of the continuous income stream is given by either this integral or this, which is what we're going to be using in these problems here. Okay, so we can plug it in and work with it a little easier than doing a full integration. Okay, and this formula is just coming because it is R of t is a rate, a derivative. So that means if we take an integral of it, we would get a total value. Okay, so this is representing a total value of accumulated future value. So the present value will look a little different, and it gives us a dollar amount. All right, so let's try it. So it says find the accumulated future value of the continuous income stream at rate R of t equals 85,000 for t equals 20 years and interest rate K equals 3.2%, compounded continuously. Okay, so our future value, so they use A, capital A for that. So that's our future value in this problem. Sometimes they change the letters. Okay, so future value is A in this scenario. The accumulated future value, let's underline, sorry, accumulated future value. So accumulated, there, future value, capital A is equal to R of t. So let me write down the full formula though, and then we'll change those letters into their numbers, the variables. Okay, so we have capital A is, they say R of t is 85,000 over K. Now, just like the previous compound interest problems, this percent should be changed to a decimal. So we would do 0.032 and then parentheses E to the same 0.032 times T, which is 20, and then minus 1. Okay, so as long as we type it in just like that, we'll have the same, or we'll have our final answer. All right, so we've got 85,000 divided by 0.032, and then parentheses E to the 0.032. I'm going to do parentheses times 20, and then minus 1. Okay, so I'm just going to double check that I typed in everything right. 85,000, Okay, so just make sure when you do type it in, it matches. Okay, so careful, sometimes you might do E to a number, and then like this 20 moves back down. Okay, so don't make that happen. Make sure the 20 is still up there just as it is here. Okay, and then we'll round it to the nearest cent. So we have, what is that, 2,381,000. Okay, I'm going to have to bounce back. 2,381,277 and 34 cents. There we are, done. Okay, so that's how we can find the accumulated future value. Now, an accumulated present value is a very similar formula. Okay, so the main thing is present value. So we still have a continuous income stream. They changed capital A to B instead. Okay, so for present value, accumulated present value. And notice the change, the first fraction is still the same. They switched the order of the exponential into 1, but it is also a negative k. Okay, so negative k. All right, so that's the formula that we'll use on accumulated present value. All right, so let's do this one problem here too. So it says find the accumulated present value of the continuous income stream at rate R of t equals 85,000 for a t equals 20 years and interest rate K equals 3.2. All right, so again, accumulated and then present value tells us we should use this formula. So capital B equals R of t over K, and then parentheses 1 minus e to the negative k t. And then we'll plug those values in. So we have capital B is equal to 85,000 over k, which is, again, we need to change that to decimal, 0.032. And then we have 1 minus e to the negative 0.032 times t, which is 20. All right, so there's our big setup. And then just like before, as long as we type it in the same way, we'll be fine. All right, so let's make sure we type it in exactly. So it's 85,000. All right, so I use similar numbers just to show the difference between present value and future value. Accumulated present value and future value. So we have 1 minus, and then I need to change that. Notice it's negative, so that's telling me something's wrong. So I should make sure that's still negative in my power. Okay, so now it's an exact match. Okay, so double checking, 85,000.032. 1 minus, looks good. Okay, so that value amounts, so the 125, or 1,255,000. 1,255,000 and $629.50 is the accumulated present value. Okay, so that's that. Okay, so again, we had a rate. So if we take the antiderivative or the integral, we get a total value, and that is our accumulated present value in this problem. Okay, so that is it. If you do have any questions, please let me know. Otherwise, thanks for watching, and I'll see you again next time.